Welcome to this video on coral ecosystems and how we can use proxies in those corals for past coral bleaching events. Hopefully you've seen some of the other, videos in this series where we've looked at other proxies in this series. There we go, other proxies in the series. Based on the chemical or isotopic composition of the calcium carbonate skeleton, or looking at the organic components, so maybe looking at the carbon isotopes or the nitrogen isotopes in the organic material that's trapped inside that calcium carbonate skeleton. But for this video, we're actually going to be looking at some of the physical properties of the skeleton itself. And it's kind of like, its characteristics in terms of things like the annual layers and how we can just use those as proxies. So here's an X-ray CT scan through a coral, and the advantage of X-rays scanning a coral by is that if you X-ray, you can basically then image the density of the different layers within the coral. Now, traditionally, this has been done by basically just sawing out a slab, maybe somewhere between 5 to 10 millimeters thick, and you then put that in a regular X-ray machine, and you get an X-ray image of that coral. You can count the layers. Now, the disadvantage of that is that you have to, when you're cutting the coral, you have to get the orientation of your kind of slab of coral just right, so it's perfectly aligned along the growth axis of the coral. And you can see the reason why here. So this is basically a computated tomography of basically an X-ray scan, 3D scan of the coral. So we can basically digitally slice it in a number of different ways. You can see the slice B in the middle here. You see that's slightly off the growth axis, and you can't really see any annual layering there at all because these effectively tube-like structures are being sampled through obliquely, and that's obscuring any of the layering within the coral. So that's this slice here, B, and you can see here that you can't really make out any annual layers at all. Whereas by having a computer model of your coral scan, you can slice it through any way that you want. You could even do curved slices if the coral kind of grows in a curved way. And this allows us to see, not super clearly, but we can actually see reasonably clearly, in this case, the annual layering in this coral. So some features I thought I'd just point out here. So if I go to the pen version here, you might be able to make out, I guess, these, first of all, you can basically see this, maybe if I go along here, you can see a slightly brighter band. I guess that's roughly where the annual layers are going through. There's another brighter band along here. Just get rid of those. And you can see that these layers persist through the coral, and we can kind of just about make them out. Okay, so we can see that there are annual layers in this. We can see those more clearly because we've got this computated tomography. It's a CT scan of a coral. There we go. Let's use CT scanning. Anyway, and the interesting thing here is that there are some layers which seem to show this brighter pattern. So you can see those ones that I picked out at the beginning, slightly brighter layers. And these brighter layers coincide with kind of periods in time where the corals were particularly stressed. So the brighter periods are denser calcium carbonate than the material either side of it. So the coral appears to be laying down denser material during these periods of environmental stress. And hopefully, if you're familiar with coral bleaching, you should know that there was widespread coral bleaching in 1998. Okay, so there's been layer counting. It's counting back at the individual layers in this coral, being counted back to basically work out that this was back 1998. So you can work out here 98, 99, 2000, 2001, 2, 3, 4, 5, 6, 7, 2008. So this coral was sampled in 2008. Okay, and they work back from that to work out the age. What we can do is we can use the information that we can extract from these CT scans in terms of the layer thickness, so how fast they grow, and we can convert that into a growth rate, and we can see how that is responding to changes in sea surface temperature. Okay, so we're rather than looking at maybe lab experiments or experiments where we maybe grow corals under different kind of water temperatures and see how they respond, we're able to use these kind of measurements of fossil corals. In this case, it's not that fossil, it's only kind of 10 or so years old. But we're able to do that to try and understand how these corals are behaving and responding to instances of climate change. So we can see in this particular example, as we've had a warming in the blue curve here over the last decade or so where this coral has been growing, we've had a decline in the growth rate of that coral. So it's responding to that environmental change by not being able to grow as fast. And we might want to look at that in a slightly kind of different way. We can see, zooming in on the last kind of portion of this record, it's not so much the average summer temperature that's maybe responsible for this decline. It's the occurrence of these heat waves in the ocean. So these periods where there's prolonged warmth for a few weeks, for a few degrees Celsius warmer than usual, and these kind of marine heat waves are hampering the ability of the coral to grow. So we can have, I guess, another look at another example of what might be behind this. So we can look at a variety of coral cores here. So these are regular CT scans, sorry, the regular X-ray scans, I think. But you can see in some of these in the 1998 layer, just highlight there, and I guess less obvious here. These two corals, there are prominent kind of high density banding. Doesn't occur in all corals. I guess it doesn't exist in coral C here because we're probably just falling off the end. But in 1998 in coral, this fourth one, there's no real evidence of this kind of high density band in the coral. Although in, I guess, 2010 there are. So, but then 2010 in these corals over here, we don't have any of that. This layer here is not appearing in here or here. So what's thought to be occurring here is that the corals are responding to a bleaching event by changing the way that they're effectively calcifying. So they may be calcifying a little bit more slowly, so that the crystal structure is a bit more densely packed. They're less able to grow quickly during this period, so they deposit more dense calcium carbonate. And I guess the important thing to recognise is that when I guess a coral reef community experiences bleaching, not all of the corals in that community will bleach. Some will kind of survive, and as you can see that here. So these corals here, C and D, there's no, I guess we don't really see here because we maybe don't have 1998. We certainly don't see here. This coral hasn't bleached in 1998, and these two didn't bleach in 2010, although this one and this one did. Let's get rid of those pen marks. So what we can do is look at a variety of different cores through a variety of different corals from any one locality, and we can have a look and see how the observations of bleaching from field measurements at the time compare to these proxy measurements of effectively bleaching events. So you see where we have evidence of from basically field studies, people went out and actually observed how much bleaching was going on these particular sites in 1998 and 2010. And then, I guess, some years later, people have gone along and taken these coral cores and looked at the occurrence of these high density bands within the corals. And we can see that there's actually this really good correlation between the occurrence of these high density bands and if that reef experienced bleaching. So we can see here that we get this quite nice correlation between the two. Now, I guess you can argue maybe a little bit about whether this is a valid correlation, given that the data fall effectively in two independent clusters. So you're always going to get a straight line between those two clusters. They're not really, I guess, if you're assessing the validity of a correlation, it's usually nice if the data is spread, I guess not necessarily evenly, but throughout the range in which you're looking. Anyway, that's a minor concern to us, really. It does seem, at least, that if you have a high amount of bleaching, then you're going to see a high amount of these stress bands occurring in our fossil corals. So we can use this by looking into the past, by effectively using this tool to basically do surveys of coral reefs of the past. So if we were to basically look at a coral reef, and we were to want to investigate how that responds to a particular bleaching event or a particular marine heat wave that causes bleaching, and we could do that by going out and doing some field work and surveying it as the bleaching happens. But that will only work for I guess events that haven't happened yet. If an event has already happened, then you can't go out and observe it because it's happened, which is why we use these proxy records of environmental change. And this is an example of one of these cases being, I guess, this technique being used. So we have basically two past bleaching events, 1998 and 2000. This is the islands of Palau in the Pacific. And what you can see here is that these are estimates of the occurrence of these stress bands in different settings in the reef. So we have sites being split into sites that are on the edge of the coral reef platform at the barrier. So those are the blue ones, and then the red ones are within the lagoon. So we can see here that we can compare first of all, 1998 with 2010. And from this survey, we can see that overall, there was a much more intense response to the heating during 1998, because we can see that there's a higher prevalence of the stress bands, which we infer as more coral bleaching. Compared to 2010, there appears to be less coral bleaching. So that's a useful metric. We could use that to maybe start to investigate, what was the driver? Was it hotter? Was it longer? And then what impact did that have? Or was it just that by 1998, once that bleaching event was over, all of the corals had been bleached and it had killed off all of the corals that are more susceptible to bleaching. So by 2010, only the more resilient corals remained. So we can start to ask those kind of questions by we could do that using surveys, but we can't do it kind of after the case. We can only do it into the future. So we can now use these proxy tools to go back into effectively the geological record and do these surveys post hoc. So the other interesting thing about these data is that we can start to pick about spatial patterns if we can get enough samples to do that. So we can see actually that the type of response between these two different bleaching events was quite different. So in the 1998, it seemed to affect the barrier, outer lying regions of the reef more strongly than the inner lagoons, whereas in 2010, the response appeared to be more similar. So we can start to ask kind of questions why that might have been, but we can only ask those questions if we have these kind of proxy survey data. Another example of using growth rates and these, the physical properties of the corals This is a study that Seb Henniger, who also teaches on this course, was, I guess, heavily involved in. And it's just looking at the linear extension rate of corals from basically an archive of coral reefs. So looking at how a coral grows, went through and looked at all of the different annual layers in the corals and kind of compared the width of growth layers to whether that year was particularly warm or was subject to these marine heat waves. In this case, rather than using degree heating weeks, degree heating days, they use degree heating months. So if it was effectively a degree warmer for a whole month, or I guess a couple of degrees warmer for half a month, that would be that would classify as a heat wave in this study. And they found that those years which had heat waves in that region, the corals basically they didn't grow as far. They didn't grow their growth layers were not as big in that year. So they did that for periods in time where we have good kind of oceanographic data, and then they took fossil corals which extended back in time and extended that record of when there were these marine heat waves and when corals responded to these heat waves by growing less. So they've interpreted these low growth years. So they've interpreted the low growth years as a response from a marine heat wave of the coral effectively bleaching, or at least reducing in its ability to grow in a similar way that a coral bleaches and then reduces its ability to grow. So I guess it's an indirect measure of coral bleaching. It might not actually be coral bleaching, but it might be that the coral definitely reduced in its growth rate, so something bad happened to the coral in that year. So we can have a look at the results of this study, and this was quite a controversial study when it came out. So I guess we just focus on the top graph here. So this is, these are survey data. So this is where people have actually gone out and observed the conditions on reefs through time, from I guess the 80s through to 2000. And the really striking thing about these data at the top is that 1998 was a really exceptional year. So these data, we do notice that the axis changes here. So in 1998, so I guess before 1998, there were very few observations of coral bleaching. Okay, so looking at maybe fewer than 20 per year in some years, but mostly not any coral bleaching being observed. Whereas in 1998, hundreds of observations, over 600 observations of bleaching in 1998. So I guess this event was very important in terms of coral reef science. It really kind of opened up the scientific community and I guess the wider public to the risk that coral reef habitats are suffering from climate change through increased ocean temperatures, making these corals more susceptible to these reef kind of damaging events, these coral bleaching events. So the interesting thing about this study is that it's effectively recreated that data set, but it's recreated it from a point of view of just looking at the proxy evidence for this coral bleaching. Now, the problem with the observational records is that you will only find evidence of coral bleaching if someone was out there looking at the reef at the time and noticing that the corals had bleached. So you could say that there's a potential for an observational bias in the observational data set of coral bleaching, is because maybe before 1998 people weren't really looking for large-scale coral bleaching. If these corals were bleaching, this was maybe happening far out on the reef, away from land. People were not so engaged in kind of the environment in that time than they are now. So if we actually look at the proxy record of coral bleaching, we can actually see that 1998, this year here, that was the highest incidence of at least proxy coral bleaching that have been recorded here. But it is nowhere near an extreme outlier as it is in the observational data set. So you could look at this data set at the bottom and say that, well, the proxy evidence for bleaching shows that actually there is no particular extreme event in 1998. There's basically been no change in the prevalence of coral bleaching throughout this whole record. Maybe there's less during this period, but if you were to work out the average here, maybe the average of these is maybe a little bit higher, but it's not obvious at all. And looking at the potential for observational bias, so the number of corals that are in this proxy archive, actually there are more corals here back in the 80s than there are that were sampled in the database in the 90s. So that gives some kind of evidence to support that that this isn't such an extreme event as we would have been led to believe from the observational record. So usually it's the case that it's usually better to actually have direct measurements of the environment rather than these proxy measurements that we've been looking at in this kind of series of videos. But actually, sometimes proxy evidence, because it doesn't have a strong observational bias, it can have an observational bias, but in this case, it might have a different bias. It can offer, I guess, a different view of the system. So it's not just comparing with the observational measurements. Because these are proxy data, we can go back into corals which are much older, have been living for hundreds of years, and then we can see what the evidence for kind of the long-term trends in coral bleaching are. And that's what we've basically got here. So rather than just being looking at maybe the last kind of like 30, 40 years or so, here's a compilation of data going back almost 500 years. And what we can see that over those 500 years, there's proxy evidence for, where's my little pointer gone? Anyway, proxy evidence for temperature. So the temperature's been roughly consistent over that 500 years, maybe some increase over the last 100 years, but quite a lot of variability in this region. And we can compare that to the evidence for bleaching from, or at least low rates of coral growth in any particular year. And that's what's shown in the bottom two plots, two different kind of ways of basically expressing how frequent these bleaching events are. But effectively, you can see over this long time period, we don't really see the same pattern as we do in temperature record. There doesn't appear to be a systematic kind of massive difference in the last 100 years. If anything, there might be kind of like some kind of long-term variability, but not that much. So I guess this would be a really good paper for you guys to have a read of. We might discuss it a little bit in the tutorial session if you would like to do that. It'll be fun times. But yeah, so let's I guess let's leave it there, because this is a good place to stop in terms of this video. So just to recap, so we can use I guess physical property, density of the coral, layers of annual thickness of annual layers, to tell us something a little about how those corals were responding in the past to these climate changes, at least environmental changes. Right, stop here and press the stop button.